Okay, in this video I'm going to show you how to find trig values using a triangle. So we start off with, remember, SOHCAHTOA. Yeah, SOHCAHTOA, where the sine was the opposite over the hypotenuse, the cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. The red ones just show you the shortened version of them. Okay, well, I hate to tell you this, but there are not 3, there are actually 6. So let me introduce you to 3 more. They are the cosecant, the secant, and the cotangent. Don't know why this is off. Here we go. The cosecant, the secant, and the cotangent. They're just the reciprocals of the original 3. Okay, now remember, we always have to have a right triangle to be able to do this. So notice, this cosecant is the hypotenuse over the opposite, the secant is the hypotenuse over the adjacent, and the cotangent is the adjacent over the opposite. Now, if you line those up, this goes with sine, this goes with cosine, and this goes with tangent. Okay, tangent and cotangent, because tangent is opposite over adjacent, cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. So they match up in that way. I don't know how to tell you to memorize it. I just do them all in the same order every time. That way I don't get confused. So if I do sine, cosine, tangent, I go cosecant, secant, cotangent. Then I don't get confused. But that's up to you. You'll have to figure out what works for you. Okay, so let's go back and review our triangle. So we have our right triangle here. And remember that the little box in the corner always points to the hypotenuse, if you will. Okay, so I labeled the 2 sides. So if I'm standing on angle A, this is the opposite and this is the adjacent. If I'm at C, this is the opposite and this is the adjacent. So we have a triangle here at the bottom. Let's work from angle C first. Can you tell me the sine? Well, the sine is the opposite over the hypotenuse, or 3/5. The cosine, angle C, is the adjacent over the hypotenuse, or 4/5. The tangent is the opposite over the adjacent, or 3/4. The cosecant is the reciprocal of this. It's the, just turn it upside down. So this is 5 over 3, this is 5 over 4, and this is 4 over 3. And you don't have to memorize them if you just flip them. Okay, so now if I work from the other side and I work with angle A, okay, angle A, the opposite is 4 over 5. This is 3 over 5. This is 4 over 3. And if I just flip all those over, I have 5 over 4, 5 over 3, and 3 over 4. Not so difficult. So all we have to do is flip them, and that gets us our other ones. Okay, now remember, opposite I have to look across, adjacent I can stand on, okay, from that angle. Okay, just a quick review that we did in geometry. All right, so paper's upside down. So here's what we want to do. It says we want to find the values of the other trig functions based on angle R. We are told that angle R is -3,5 and the terminal side of R is in quadrant 3. So that means I need to draw a triangle. The triangle I'm going to draw, and always in quadrant 3, is going to look like this. Okay, it's going to be like this. And I'm told that the sine of angle R is right here, is -3 over 5. Okay, so now think. This is opposite over hypotenuse. So the opposite of angle R is -3. And the hypotenuse is 5. My right angle is right there. Okay, now my good old friend Pythagoras will help me find the rest. My good old friend Pythagoras says side squared plus side squared is hypotenuse squared. So the side over here we're going to call x. And this one is my y, so -3 squared equals the hypotenuse squared. Side squared plus side squared equals hypotenuse squared. So x squared plus 9 is 25. X squared is 16. So x must be 4. Or plus or minus 4. So now which one is it? Well, which direction did I go? I went left, and when I go left, that makes it negative. So it's -4. I know that the sine of r is -3/5. What is the cosine of r? Look at your triangle. It's -4/5. What is my tangent of r? It's the opposite over the adjacent, -3/-4. Oh, goodness gracious, fix that. Oops, that's a 4, not a 5. Okay? And then I flip them. So the cosecant of r is, I don't care how you write it, -5/3. The secant of r is -5/4. And the cotangent of r is 4/3. Not so difficult. Okay, so far so good. Let's do that again. Notice in quadrant 3, this is what my triangle looks like. As a matter of fact, while we're here, let's just draw all 4 triangles. If I'm in quadrant 1, it's going to look like this. If I'm in quadrant 2, it's going to look like this. If I'm in quadrant 3, we already drew it. And if I'm in quadrant 4, it's going to look like this. My right angle is always going to be on the x-axis, like so. So if I'm in quadrant 1, or if I'm in quadrant 4, or if I'm in quadrant 2, and here's what it looks like if I'm in quadrant 3. All right, so far so good. Well, let's keep going. So I have 2 more like that. So first of all, the tangent is 15/8, and I'm in quadrant 4. So 15/8. Okay, tangent is 15/8, and I'm in quadrant 4. That is not correct. Let me fix that here. It's -15/8. Thank you. All right, so here we go. We're going to draw our triangle. We're in quadrant 4. Quadrant 4 is down here. It's going to look like this. I have it like this. Tangent is opposite over adjacent. Opposite is -15. Adjacent is 8. What does that make this one? I don't know. Let's find out. So I know that 8 squared plus -15 squared is my hypotenuse squared. We'll call it C. That's fine. So 8 squared is 64. And 15 squared is 225. So that's 289. And I happen to know that makes this 17. Now the hypotenuse will always be a positive number. The hypotenuse is always a positive number. So I know that. So I need to find the sine of r, the cosine of r, just to be consistent. I already have the tangent, but all I have to do is write it down. The cosecant of r, the secant of r, and the cotangent of r. So this is pretty straightforward. This is what we're filling in. So I know this one is -15/8, which makes this one -8/15. The negative sign can float, it's fine. So if I take a look, the sine is the opposite over the hypotenuse. So -15/17, which makes the cosecant 17/-15. The cosine is adjacent over the hypotenuse, so that's 8/17, which makes the secant 17/8. Not too bad. Let's do that again. This time we're in quadrant 2. Quadrant 2 is over here. And the cosine is -7/25. So that means the adjacent, my adjacent is down here. And my hypotenuse is 25. So I do my Pythagorean theorem. -7 squared plus, we'll call it y squared, is 25 squared. So 49 plus y squared is 625. So 625 minus 49, oops, clear that, is 576. I use my calculator here of 576. I get 24, so y is positive or -24. I went up, so it's positive. It went up, so it's a positive value. So now I just need to find my other trig values. So I have the sine of r, the cosine of r, the tangent of r, the cosecant of r, the secant of r, and the cotangent of r. I know the cosine is -7/25, which makes the secant 25/-7. Looking at my picture, the sine is 24/25, which makes the cosecant 25/24, and the tangent is 24/-7, which makes the cotangent -7/24. Not so bad. So we've done one in each quadrant now, so we or almost every quadrant now. We haven't done one in quadrant 1. We'll do it on the next page. Okay, so that's the basic kind. Now we have this kind, which is the same thing. It's just written a little bit differently. Instead of giving you an angle, I gave you a point. So here's what it looks like. First of all, we need to draw a picture. And the point 2, 2 is right there. So here's my triangle. I draw the triangle based on the point. I have the point. I know this is 2. I know this is 2. My good friend Pythagoras takes me the rest of the way. 2 squared plus 2 squared equals the hypotenuse squared. So 4 plus 4 is the hypotenuse squared. So the hypotenuse squared is 8, which means the hypotenuse is 2 square root of 2, because I have to take the square root of that. So 2 square root of 2. We're good so far. So let's find all 6. The sine of r, the cosine of r, the tangent of r, the cosecant, the secant, and the cotangent. Here we go. The sine is opposite over hypotenuse. 2/2 square root of 2. Simplify that. We have 1 over the square root of 2. You can leave it like that. If you would like, if you prefer, you could do square root of 2/2. Cosine, same thing. 2/2 square root of 2, which is 1 over the square root of 2, which is the square root of 2/2. The tangent is 2 divided by 2, or 1. Flip them all over. This becomes the square root of 2. This one becomes the square root of 2. And this one is 1. Pretty straightforward. Let's try that again. This time we have the terminal side contains the point -8, -6. -8, -6. -8, -6 puts me right there. Here it is, -8, -6. I got to find that third side. So -8 squared plus -6 squared is the hypotenuse squared. So 64 plus 36 is the hypotenuse squared, so 100. So h must be 10. Why didn't it's plus or minus, but I know since it's the hypotenuse, it has to be positive, because remember, the hypotenuse is the radius of a circle, so it's not going anywhere. All right, so now we have to find the sine of r, the cosine of r, the tangent of r, the cosecant of r, the secant of r, and the cotangent of r. Here we go. The sine is opposite over hypotenuse, -6/10, which reduces to -3/5. Cosine, adjacent over hypotenuse, -8/10, which reduces to -4/5. Tangent, opposite over adjacent, -6/-8 is 3/4. And flip them. -5/3, -5/4, and 4/3. Got ahead of myself there. And that is how we find the angle measures given, or the 6 trig functions given those two situations.